Hi everyone. Today we are going to study a very important and basic concept of chemistry, that is significant figures. We can determine the uncertainty associated with an experiment from the significant figures. For an example, let's take a number 25.85. Here the last digit 5 is the uncertain one, right? This number has four significant figures: 2, 5, 8 and 5. What are they? 2, 5, 8 and 5. Here the last one is uncertain. Let's take some more examples. 257, 257. Here the number of significant figures are 3. What are they? They are 2, 5 and 7. Because all the non-zero digits are significant. Here 2, 5, 7 all are non-zero. So the number has three significant figures. If the given number is 10, 1, 0, then it has only one significant figure, that is 1. As 0 is present on the right side of the non-zero digit and at the end of the number, it has only one significant figure. However, if a decimal is put right of the 0, that is, in the second case, it has two significant figures. Both 1 and 0 are significant. Okay? Let's take some more examples. If the number is 0.005, then it has only one significant figure, that is 5. Because the zeros present before the first non-zero digit 5 are not significant. These zeros before 5, that is left to the 5, are not significant. Similarly, there is two significant figures in 0.0050. Here the 0 right to the 5 is significant, but the two zeros left to the 5 are not significant. Let's take one more example, 0.00500. Here it has three significant figures, 5, 0, 0. The zeros present before 5 are not significant. Let's take some more examples. Got it? All the zeros after non-zero digit 5 are significant, but the zeros present before the non-zero digit 5 are not significant. Okay? Let's take one more example. If the given number is 1.0970, it has five significant figures. What are they? They are 10970. Here 10 is at the end of the number and 10 between two non-zero digits. So this number has five significant figures. If we are asked to round it off to four significant figures, then it will become 1.097, because the last one, 0, is less than 5. So the penultimate digit 7 is kept as such. Okay, let's see rounding off in details. Let's take some more examples. 159.76. It has five significant figures. What are they? 1, 5, 9, 7 and 6. The last digit is greater than 5. So upon rounding it to four significant figures, the penultimate digit is increased by 1. So the final answer becomes 159.8, which has four significant figures. Okay, let's take some more example. 159.73. Here the last digit 3 is less than 5. So upon rounding to four significant figures, we have to keep 7 as such, because the last digit 3 is less than 5. So there will be no change in 7. So the final answer after rounding to 4 significant figure is 159.7. Now let's see some more example regarding addition of two digits with proper number of significant figures. Let's say 11.59 plus 1.689. Here in the first number there are two digits after the decimal point. What are they? 5 and 9. However, in the second number, it has three digits after the decimal points. 6, 8, 9. Upon summation, it became 13.279. But the correct way of representation is 13.28 after rounding, because the last digit 9 is greater than 5. So there is an increase of plus 1 to the penultimate digit 7. So the final answer became 13.28. Okay. Any doubt? Okay. Let's take one example on subtraction. If it's given 11.59 minus 1.689, then it became 9.901. But after rounding, the final one should be eliminated as it is less than 5, and the previous 0 is kept as such. Okay, so two digits after decimal points, because 11.59 has two decimal points. Okay, let's see multiplication and division of two numbers with proper significant figures. Let's see. 1.5 multiplied by 3.00. In 1.5, there are two significant figures, 1 and 5. In 3.00, there are three significant figures. So, upon multiplication, the final answer will be 4.5, not 4.50, because in 4.5, there are two significant figures. Okay? Okay. Let's take one more example. 1.50 into 3.000 is equal to 4.50. Here in 1.50 there are three significant figures, and in 3.000 there are four significant figures. So in the final answer there should be three significant figures. What are they? 4, 5 and 0. Similarly, for division we will follow the same principle. 3.000 divided by 1.50, the final answer is 2.00 with three significant figures, 2, 0 and 0. Because the given numbers 3.000 and 1.50, 1.50 has three significant figures. In the second case, 3.00 divided by 1.50, the answer should be 2.00. In the third case, 3.00 by 1.5, the answer should be 2.0, where 2 and 0 are significant. Let's take some more example on log and antilog. Log 5.2 base 10, the answer should be 0.71600. But upon rounding, the number will become 0.72. As the given number 5.2 has two significant figures, the answer should be rounded off to two significant figures. So, the final number should have two digits after the decimal points. Okay? In 5.2, there are two significant figures. So, the final answer should have two digits after the decimal points. Similarly, log 20.0 base 10, the final answer is 1.301, after rounding, because 20.0 has three significant figures, so the final answer should have three decimal points. Similarly, if we take natural logarithm, that is ln of 20.00, the final answer should have contain four significant figures. Okay, sorry, five significant figures. That is four decimal points. Four significant figures in 20.00. So the number has four decimal points. Let's see the rounding off in antilogs. Let's say 10 raised to the power 2.0, the final answer is 100, because 2.0 has one decimal point, so the final answer should have one significant figure. If we'll take e raised to the power 2.5, the final answer should be 10, because in 2.5 the number has one decimal point, so the final answer should have one significant figure. E raised to the power 2.50, here 2.50 has two decimal points, so the final number should be rounded off to two significant figures. Okay, let's take one more example. E raised to the power 2.500. Here 2.500 has three decimal points. The final answer should be rounded off to three significant figures. Hope you liked it. That's for today. Like, share and subscribe. And please do not forget to comment below on which topic you want the next video.